Okay, so for this graphing concepts in trigonometry, for now you're still studying sine and cosine, right?
Yeah.
So we'll start with the most basic form. The functions follow this format: a sine bx or a cosine bx. A, B are numbers. They tell something about the graph of the function. Okay, did you learn that in school?
Yeah.
Like for example, y equals 3 sine 2x. This number tells something about the graph. What is that all about?
The starting point, like the principal axis or something.
Okay. Well, it is related to that, but this number actually tells you the amplitude of the graph.
Okay.
When we say amplitude, remember that the graph of the functions, these two functions follow this way. And exactly in the middle, okay, when you measure from this line up to that point, the highest point, you are measuring the amplitude. So this red mark is the amplitude. How high from the middle is your graph. If you measure from this line down to the lowest point, you get the same number. Okay, so in relation to this example, y equals 3 sine 2x, the amplitude of the graph will be 3. So what if you have a function with a negative 3 sine 2x instead? Will your amplitude be negative 3?
No.
No.
Because the amplitude is a midpoint, so it's same up and down.
Same. So it's a measurement, it's a length. So the amplitude, even if it's negative 3, we take the positive value and the amplitude is equal to 3. Okay? So always remember, it's from the middle and then up to the highest point, or from the middle down to the lowest point. Okay? And it can be easily identified by just looking at the number there. Okay, what about the b? If you look at the function a sine bx, there is this number b here. If a tells something about the amplitude, the b,
Period.
the period, and there is a specific formula for the
360
period.
divided by b.
Very good. So period is 360 divided by b. Okay. Currently, you're still using degrees. In other textbooks or references, they use pi, radians. And in radians, 360 is 2 pi.
Okay.
So we divide 2 pi by b.
Okay.
But I think this will be learned maybe after the degree versions of the graph. Okay, so what does it mean by a period?
Like when the graph starts repeating itself.
Repeating itself. Okay, so for example, where we can start anywhere on the graph, but the best way to get a starting point is when you have the point at 0, 0 or anywhere on the y-axis. So a typical sine function will follow this way.
Yeah.
And once we reach this point, it starts to
repeat
the pattern. And this length from this point to that point is 1 period. And it can be measured by simply getting the value of the b. Okay? So if our function is y equals 3 sine 2x, then what will be the period for this graph?
3 sine 2x, 180.
180. So 360 divided by 2, or 180 degrees. Meaning to say, if you start counting from 0, the pattern will end at 180 degrees. Okay, so these are the basic ideas that we need to know. Now what if, so let's go to the more advanced functions. What if we have a, in this paper, y is equal to negative 3 sine x plus 30 degrees and then plus 1. This is when you analyze like the movement. Okay, well, there's actually no movement, but it seems like the basic function is moving to from those points to a new set of points. And the movement, so what we say, the movement is determined by this number and this number. Okay, what did you learn in school? How will this number affect
I'll move
or
left 30 degrees.
left by 30 degrees? Okay, and then the plus 1 will be
Up by
up
1.
by 1. Okay, very good. So this will be the movement. But how is the period and the amplitude affected, or are they affected at all? What do you think will be the amplitude for this graph?
3.
The amplitude remains the same, the absolute value of -3, which is 3. What about the period?
360.
360
Yep.
divided by
1.
1, because there is just, actually the 1 will be here.
Okay.
Okay, not even on the x. Okay, it's the one outside the parenthesis. Dito lang.
Oh.
Sorry po. Okay. Then you take it.
Okay, so 360 divided by 1 is still 360. So we expect the graph to repeat its pattern if we put the starting point. Well, the point is not necessarily on the 0, 0, but if we start like anywhere there, the pattern will repeat after 360. Okay, idea is clear? Okay, so how do we exactly graph y equals -3 sine x plus 30 plus 1? What did you learn in school?
So like the amplitude will be -3.
Which will be +3.
Yeah, +3, and then
Mm-hmm.
moves right 30 degrees and up 1.
Up 1. But how will you show that on the graph? Like how do you determine exactly this point will be at a certain value, like degree?
You start with the original sign.
You start with the original. Okay. So instead of graphing this directly, we first graph y equals -3 sine, and there's no number there, so it's just 1, and then x. Right?
Yeah.
So graphing this, it will repeat the pattern after 360 degrees. Did you learn any like quicker way of graphing in school?
I don't know.
Like once you have the period, because the
Yeah.
behavior of the graph will be the same all throughout.
Yeah, I think so.
So, well, in other references, not the fastest way, but a faster way of graphing is once you identify the period, you divide it into 4 areas. So first we take the half, 180, and then half of the 180, 90, and then 270. And in the pattern, this will be your 360, this is your 180, and this will be your 0. And in between is your 270 and the 90 and the 270. Did you learn that?
Yeah.
Okay. So, well, in concept, to find the points, we place the angles, so this is 0, we place the angles one at a time to x, and you will get a specific number for y, right? And I'm not sure if this was discussed already, if this is a negative number, then the pattern will be reversed, right? Going down instead of going up first. And for the sine, you always start at...
Is that because of the negative?
Because of the negative.
Okay.
Well, actually, if you plug in every angle that we have here on the x, it will give you the exact points that you need. For example, if we will be putting the 90 degrees on x, you will get a value -1. And that leads you to the first point, well, after the 0, 0. So 90 and then -1. You place 180 on the x, you get a y value that is 0. You put 270, you get 1. You put 360, you get 0. And that is by just substituting the values on the x. And then just trace the graph, the points, and you will be able to estimate the graph of the function. And this is expected to repeat. Okay, now however, this is not the graph of the function that we want to graph, because the function that we want is plus 30 and plus 1.
Yeah.
But how will this graph help us?
But shouldn't the amplitude be 3?
Okay, so when we place, sorry, let's correct that. For a typical sine x without the 3, it will be negative 1 to 1.
Yeah.
For the negative 3, because the amplitude, so this will be negative 3,
Okay.
and this will be 3. Okay, so it will be stretched by
Multiply.
a multiple of 3 or a factor of 3. Okay, so having this, so let's graph now the function. So every point will be moved 30 degrees to the left.
Yeah.
0 moving to the left by 30 means minus 30. So this is negative 30.
Okay.
The second number 90 moved by 30 to the left is 60. And then 180 minus 30 is 150. And then 270 minus 30 is
240.
240. And then 360 minus 30 is equal to
330.
330. And it's up to you how will you space them properly in your axis. Okay, well, negative 30, assuming this is the length 30, so that's negative 30, and you can maybe count by 30s.
Yeah.
30, 60, then 90, and then 120,
Yeah.
150,
180.
and then you can now like estimate. So you have 180, and then
210.
210, and then the next point is 240, and then 270. Next to 270 is 300,
330.
300, and then you have your 330. So these are the values that you need.
Yeah.
Well, following the pattern of the original function, or I mean the function wherein we base this function, is going down and then up and then n at the last number.
Yeah.
So we start with negative 30, but let's incorporate already the plus 1.
Okay.
So we have moved it,
Up 1.
so now we have to move it by 1, up by 1. Originally, the locations are 3 and negative 3, so up by 1, you have 4, and then the negative 3 will be negative 2. The middle point will be at 1.
Yeah.
Right? So 0 goes to 1, 3 goes to 4, negative 3 goes to negative 2. And this will be your guide. Just like imagine, you don't need to trace it, okay, but try to imagine there's a line there. So we start with negative 30, next point
90. Negative
60, and then we intersect at 150. We get the highest point at 240, and we end with 330.
So look like that.
So it's going down. So it's similar, well, it should be similar to the negative 3 sine x, but with a movement 30 to the left and 1 unit up. Okay, so once you understand how to graph, like even just sine function, you can use those ideas to graph the cosine functions. Okay, any question? Okay.